Hello, in this video we're going to be doing checkpoint 5.27. They want us to evaluate this integral. It's a triple integral of r, z, sine theta, r, dz, dr, d theta, where z goes from 0 to 4, r goes from 0 to 1, and theta goes from 0 to pi. Now, in what's written here on the side, you can actually see the limits are specifically z is equal to 0 to z is equal to 4, but if you can just match up the differential with the limits of integration, then it should be clear that we're dealing with which variables we're dealing with. They don't ask for this, but I think it might be a good idea to try to figure out how this thing might look like. If we take a look at the inequalities where z goes from 0 to 4 and r goes from 0 to 1 and then theta goes from 0 to pi, we can try to imagine how this thing looks like. So the idea behind cylindrical coordinates, which is where we are, is that if you have constant limits for your integration, you're going to have some solid form of a portion of a cylinder. Let's work from the bottom up. We got theta. If we look at theta, remember theta is on you can think about theta on the xy plane. And then we can translate that idea to 3 dimensions. But in the xy plane, theta goes from 0 to pi. So that's the top part. That's the part on the positive y-axis. And the radial distance goes from 0 to 1. So this would just be a semicircle of radius 1 going along the y-axis. So it would be something like this. So that's that part. And then the z goes from 0 to 4. So you just move up 4 units. And you can do that by going up 4 units. 1, 2, 3, 4. And up 4 units here, you'll get your cylinder shape. So this looks like half of a cylinder that's going towards the y-axis, and it goes up 4 units in the z. All right, now that we know a little bit about that, we can just do the integral. And in terms of doing this integral, I would like to use or take advantage of Fubini's theorem, where you can place it in any order you want. Also part of Fubini's theorem is taking a look at this integral. And if we have integrals that are just factors and you have constant limits, if you have these factors, you can take one factor out of the integral because it's constant. For example, with respect to z, z is the only variable there, and so technically you can take the r, there's 2r, so that's r squared sine theta, you can take that out, and then all you would have left is your integral for z. So what that means is that you've taken everything out. You have z going from 0 to 4 dz. And so that's just one part of the integral, and you've taken all the other stuff out. And so if you've taken that out, that means you're dealing with a theta integral. Let's deal with the theta integral. Maybe do this in another color. If we have a theta integral, everything is constant with respect to theta except for sine theta. So we have the integral from 0 to pi. Those are the limits for theta of sine theta d theta. All right, and then one more. After you've taken all that stuff out, you have an r squared, because there's an r and an r there. And usually they wrote it like this instead of saying r squared explicitly, is because the dv differential for triple integrals gets translated into r dz dr d theta when you're doing triple integrals. And so just like the polar coordinates, you have an extra r. And so that's your extra r. So there's an r and an r, so that's r squared. And remember, your r limits go from 0 to 1. So integral from 0 to 1, r squared dr. And that's it. Those are your integrals that you're going to compute separately instead of looking at it as an iterated integral, which you can do, by the way, if you want. But this seems like it would be easier. So we have 1/2 z squared from 0 to 4. We have negative cosine theta from 0 to pi, and we have r cubed over 3 from 0 to 1. This will give us a 16 over 2 is 8. This will give us, this is like the one arc of the sine. It's a pretty popular problem, but this will end up being 2. Because you'll have -1 minus -1, so that'll be +2. And here it's just going to be 1/3. Okay, we multiply all that, we're going to get 16 over 3. And that's it. All right, I hope that helps, and good luck.